Thanks again for having us today. It's precious for us to always be involved with ClueCon. For those that don't already know, this is where basically Homer started. So it's been our first home. So a little bit about the presentation. The monitoring is boring. So this is a triple clickbait, of course, partially because the trick is in the word. So boring is as a noun refers to drilling a hole or the hole itself. And the more I thought about this, the more I saw the analogy with what we do. So when an engineer makes a boring into the network, they can take a sample and they can learn about the history of the traffic, much like we do in geology or other realms. So this is a little bit the spirit of the presentation. And on the other side, monitoring is really boring. It's something that's it's tedious, it's not fun, it's mostly used in a context of bad news and so on. So in this presentation, I'm going to try to share a little bit how and what it is that we managed to do today with monitoring, and also where we're going into the future with this. So for those that are not familiar with this beard, I'm Lorenzo Mangani. I'm a co-founder with Alexander Dubovik of QXIP, which is the company that we have created for Homer. So from the initial, little open source project into a little business, into the company that we are today, we decided to create a container for it so that we wouldn't be anybody's slaves, so to speak. So not depend on, anything other than our users to stay alive. So we do research and development, and we are obsessed with, of course, monitoring, troubleshooting, especially in the VoIP and RTC realm, which is where we made our small, career. We're lucky because we get to deal with a huge variety of counterparts. So from individuals, tiny startups, little projects, all the way to large corporations that do value the monitoring aspect of things. And more of those are, of course, using open source, and that's where we fall in. We're self-sponsored, meaning, again, that we don't depend on anyone to continue doing what we're doing. We're independent. We don't have any shadows, so all of our key code is and has been public for a very long time, so it's free of patents or any risks of using. And we have this open source Robin Hood model where basically the rich is paying for everybody else. So we found the sweet spot between being able to do the open source that we want to do and isolate a few features that don't hurt anyone to pay for it, really. So the concept is to do one thing and to do it well. So it's monitoring that we do, and it's monitoring that we have spent the last decade perfecting our way, which is by no means the best or the ideal for everyone, but it's what we came up with, what we use ourselves for many years, and what we offer to our community. Our strength, of course, is the integration of the HEP encapsulation protocol, which is the reason why we exist, really. So the fact that our encapsulation protocol is native in many platforms has precursed the present. So when we did it, it looked like, okay, but I can use a sniffer. Okay, but I can use TCP dump. Okay, but I can use ngrep. Today, good luck with TLS. If you don't have an integrated sniffer, you're gonna have a hard time doing it clean. So thanks to this concept by Alexander at the beginning that has been evolved, again, first in FreeSwitch and then in all of the other platforms that enrich our environment, we continue collecting, that experience, those details, and trying to, put them back into our project. So, I don't know if my slides, okay, here we go. So it's going back and forth. There's a little bit of delay. Sorry for swapping back and forth. So you know us, of course, for Homer. And today I'm going to introduce a new piece of our stack that we've been working on for the last year. But really, our design is modular. So Homer is not even an application per se. It's made of multiple parts itself. So, all of those things are more like containers for modular, tiny little tools that work together and that we can more easily maintain. So rather than, the monolith that we used to be, we're more and more fragmented into a bunch of little tools that take individual roles, like capturing packets, indexing them, transforming formats, reading pipelines, pipelines, and then approaching, of course, the gathering of data from as many angles as possible. A few things that we keep out exactly that sponsor everything are related to lawful interception and commercial deployment on very large footprints, where, of course, there's always a budget. So what is really Homer? We already all know, so I'm not going to stay on this long, but it's we like to think of it as a packet capture time machine, where you can go back in time or look at the real-time present the same way, especially from a signaling, statistics, and logs perspective. So you can see what your system are doing, what they're exchanging between them, investigate those things for a number of purposes. The version that is shipping, which comes with probably, I should say, way too many options. So it's something that typically confuses people, but you can attach it to a bunch of backends, databases, choose how you're going to use this data to your benefit. Many, go just with the default, so they're going to use our UI, and they're going to be looking for signaling and, the classic things. We're going to have a workshop in a couple hours or so I'm not going to get into too much detail, but we'll show you later, for those interested, how you do it, how you leverage these things. But the reality is that it's really boring. Right, so many people actually installed Homer a whole lot of time ago, 5-10 years ago, and they still use it the same way. So it's incredibly boring and it's incredibly static, mostly because it's a tool, right? It's a boring tool to do troubleshooting to make our life easier, but it's nothing fancy. It just sits there and only basically gives you good news or confirms, negative events. It doesn't do anything exciting. I mean, it's tables, it's charts, nothing really interesting. It sends you nasty alarms, never arose, never ask you on a date. It's boring, right? So this is where we connect. And how do you make VoIP boring? In our opinion, is by just making it simple to get things done. So from, skimming through your signaling, finding what you want to find fast, using, different approaches, whether it's forms, auto-completion, we just want to get there fast. What are we looking for? How do we get there? How do we find calls? How do we correlate sessions? How do we zoom into a packet without having to care about it in real time, right? So having a system that just collecting all of those things for us creates an incredible data set that we can use for a large number of tasks. The boring one, of course, is looking for calls, like, finding a call between A and B that might or might not have had a problem. Filtering data by quality, finding the good, the bad calls, creating all types of reports. So like looking at the experience of a user over time. What has this guy been doing for the last week? This is, by the way, Alexander's phone. So he made 66 calls between the teams. He spent 127 minutes on the phone. We can see how their calls are distributed. The methods of those calls are distributed. So it's really easy to just look at things from the sky and change the way we look at things. So we can go from, the standard KPIs, super boring, that everybody's used to. Those are generated in real time from signaling and synthetic transactions. If you use one of our advanced agents, you can have MOS and quality calculations, and we can use those in real time to find anomalies without even knowing that there's a problem. We can just look at data sets, use various models. In this case, you're looking at the Z-score to just filter bad things out. Who made a bad call? It's this guy at that time. We can use passively all of this data to understand how our pipes are being used, which systems are involved, which users are consuming our network by amount of calls, by minutes, how is their quality, which trunks they're using. This is all things that today became so easy and so boring that they are basically default features. All it takes is to configure them. We can look at passive timers. This is also quite the thing. So, right, it's not just collecting methods, but we can also start tracing the timers of methods and events. Look at how many devices are right now in a state of registration before they expire on a certain IP. We can go and trace, as you know, events per call. So we can look at RTP and RTCP statistics for individual calls. and we can see how the different legs of a call are being used, if the experience on the RTP matches the one reported by RTCP. So on a one-per-one basis, we do a really good job. But of course, when you have all of these data together, you can just look at it as a whole. So like, how is my network doing? How are all of my reports looking? And this way we can go hunting for like anomalies, flexions of quality, or just anything else that falls outside of our SLA, either from quality or service perspective, and just solve the problem as it happens if we're fast enough. We can see the quality of our trunks this way. So it's really easy with our system today to just give everything a name. So tell me the quality between two of my trunks, or between me and all of my peering partners for all of the traffic, or for maybe a specific destination, so that we can immediately see how things are going without ever having to communicate with any of the systems that are handling those calls. Because, of course, if something has a problem, it's unlikely that it's going to declare it itself. We can go hunting again for specific events, right? So I could look at my network and say, okay, show me if there was any packet loss anywhere. And there was. From my Valencia office back to the PBX, we have a little spike, and I can go there and I can immediately find when it happened, what it affected, which user was behind it, and so on and so forth, without ever having to ask that user to make another call. We can use the same to compare data back and forth. So how are two of my trunks or two different routes performing? In this case, we're looking like at a severed call going through subspace or not. So, different things that we can do. Codec distribution, which codecs are used by my services and where, right? So maybe we enable a new codec. We want to see our devices using it. Is anybody actually picking up or being allowed to do it, or vice versa? Is anybody using a codec that I don't expect? Who are my good and bad actors on the network? Find me all of the IPs that had the best and the worst calls on my network. So again, all of these things can be used to group VoIP together, and we think that we have one of the best platforms out there to do it. But there's always a but. What about WebRTC? You'll find specialists out there that will tell you that Homer is not a product to monitor WebRTC, and they're dead wrong. But they're right about something. It's not the same as VoIP. So there's very little in common with the way we've been building our platform up until now and the way things are going into the future. So with the growth of WebRTC and the growth of custom everything, there's no more default signals. There's no unique way to determine identities. We have SFUs, MCUs, multi-peers, peer-to-peer, multi-party, you name it. Browsers change all the time, and so their reporting changes. We have a bunch of different libraries that do the same job, a little different. It's a disaster. And we know about this because, behind the scenes and quietly, we've been doing the job. So from the beginning, when we started doing some people call it SIP over web sockets with the systems that we know, which basically it's built in, so we can do that out of the box. Growing out of those, starting to support SFUs, we did a lot of work with Lorenzo Mangani and Janus. They helped us greatly understand the dynamics of this, different environment, and how it's radically different the way we troubleshoot it from VoIP. We created with them collectors for the Janus events, did the same for MediaSoup. And then, of course, we started on the other side. All right, we got the server side. How do we do the client side? How do we do browsers, right? They're all different. So we started, can we do custom handlers in the applications? No. Can we do integrate generic collectors? So can we take observe the RTC stats, all of these things that you might be familiar with, and collect them? Can we do it in a decentralized fashion? So we did the homework. And the two main categories that come out of this are basically server side and client side. So we had to come up with a way so that we could, collect this type of metrics, events, signaling events, and so on and so forth, which have, a very different shape from those that we're used to with SIP. They don't have a stable schema unless they come from server side. So, just a new environment. And the research is telling us that, yeah, people are doing this, of course. Everybody is running the system, so they must be troubleshooting them, right? But nobody shares the same approach. There's no one tool to do it. There's a lot of activity in the automated testing field. So, services that will tell you if you're good or bad, but otherwise you're left on your own. If you want to understand the quality of your own WebRTC services or of the users of your services, you're toast. And we don't even know what we're talking about. Is it logs, events, statistics, time series, JSON objects? What is what? What do we use to find out what's really going off, right? So some typical scenarios are like setup negotiation, just like in classic telephony. But here we have also candidates, codecs, peers, and we got to look at statistics in a way that's not correlated to a call, but rather to a browser with perhaps a user that's attached to an SFU. It's really complex. So after trying everything to solve this problem, we didn't have a solution. So we kept going back and forth between time series or indexing everything or a mix of the two, and none of those was long-lived. It was always falling short somewhere. So a lot later, maybe a little bit also thanks to COVID, which gave us a nice break to stop and think about things, we came up with something of our own, which we call CLocky. CLocky is not our own invention. It's a smart idea. It's a LogQL API that we built on top of ClickHouse. ClickHouse has been our database of choice since a few years, where this is what we're using to build all of our bleeding edge solutions, and now we address scale and massive inserts. So we took this wonderful database, which of course requires some advanced skills to be used, and we took some concept from Grafana's Locky, and especially the LogQL language, which is natively present there. So we wanted to do something for a platform like Grafana that has 1 million users already, connected to the data that we can materialize out of WebRTC, or really just about anything, as you will see, and make it easy to be used. So this is designed for massive ingestion of unstructured data, whether it's logs or JSON objects or anything in between. It goes after the idea that we're going to read only a small percentage of what we write, assuming that most of it is going to be good or normal, and we're going to concentrate on what's not. So we want to quickly be able to analyze something into a system without knowing its schema, without deciding a schema, without indexing anything. And how do we do this? So I chosen a couple of examples here just to give you an idea. It's going to be about WebRTC. So we have two sides, right? So we have browsers that are using our services, and then we have servers or SFUs, MCUs, whatever you want. In this case, I'm going to use Janus because it's one of my favorites for this example. So how does it work? I'm running in the slide. We're going to have a collector. You can choose whatever it is. You can use RTC stats. You can use your own extension, whatever it is that can take the statistics and send them somewhere. We provide our own tool, which is Pastash. I'll show you in the workshop how it works. So we can collect statistics from browser servers, anything you want, not just VoIP. In this case, it's abstract data. When this data makes it into CLocky, we can start filtering for it. So in this case, I'm just looking at some RTC stats here, which is just as confusing as always. So I'm filtering by type WebRTC, and this is showing me all of these logs that I'm collecting. They contain the data I want, but I don't know their shape. I didn't prepare for them. I didn't do anything. So first things that we can start doing here is approaching them like logs. So we can grep through them. If we know an ID or something that we're after, we can immediately find it. Mind, all of the responses here are sub-second. So everything is designed to work really, really, really fast. Once we know the data that we're after, we can start looking at its shape. In this case, it's a JSON object. So we're going to pipe it through the JSON parser. So we take these logs super fast from ClickHouse. We pipe them through a parser, which can be simple or complex. We can take all of the objects or just some of them. In this case, we're interested in a specific data type. So I want to find everything that can be parsed to JSON and as a data type transport, basically all of my transport reports. And these transport reports will have data that I might be interested in using for as a value, in this case, the bytes sent. I want to know how many bytes this client has been sending over time. And I want to group the statistics by host and ID, which is going to be the IP and a unique identifier of the browser. And this is how you do it. Just like magic, we take this few information that we have learned in real time. So, okay, this is my event, it's JSON, parse it. Oh, this is the data type that I'm interested in to transport. This is the metric that I want to create, bytes sent. And then you group it by ID and host, and we generate a synthetic time series out of this in real time. Boom. Same we can do with Janus events, of course. So Janus events are, not that different. They just have a more structured and stable shape, and they tell us about, of course, what the SFU and its plugins are doing. So we do the same here. Filtered by my Janus instance events, I want only type 32, which are going to be the media reports. It's a JSON object, so I'm going to parse it, and then I'm going to unwrap it. So tell me the bytes sent in the last event, group it by handle ID and opaque ID. This could be anything. So again, it's a way to milk time series and logs, really. So you can filter through these events in whichever way your instinct tells you. You want to see them? Fine. You want to draw them? Fine. You want to make a dashboard with them? Fine. So it opens up ways to watch our data. And of course, the validation is, can this be used at a massive scale? Can we use this to watch other tools? So it's not just designed for us, but in general. And super kindly, our super dear Andreas and his new CIP front came to our rescue. And they gave us basically all of their logs from the automated testing suites that they can generate, of course. So we took something that can generate massive amounts of logs, signaling, statistics, streams, and so on, and we tried to put it in to CLocky without any structure, without preparing anything. And sure enough, within a week or two, everything was integrated. So this is not just for engineers and hackers to open in Grafana, but it's a full suite of that can be integrated at any level. So in this case, we can build real-time dashboards of the tests that CIP front is running, and they're displayed in real time in their dashboards. And I guess it saved them a significant amount of time in terms of engineering everything, choosing the way, how do I want to index it, how many types I have, and so on and so forth. This is a new way to do it, which puts the cost basically at the end. Just boring tools that we use to do a boring job. But if it sounds exciting, you should really check out our repositories, our website, give these things a try, or maybe just jump into our metrics channel and have a chat with us to tell us your ideas. This, again, has been around for a long time. It does certain things really good, others not so much. But we're nice people, and we're always looking for the feedback of our community. If you're interested in any of these subjects, there's other presentations that we've been giving. Last night I was on the Altinity ClickHouse meetup, where I was explaining more about CLocky, how it came to be, and so on. So it's all about open source. And if you love open source, please remember to support open source before you ask open source to support you. This is really, really important, not just for our project, but for all of them. We're trying to do something, we depend on each other, and it's really important that we keep this relationship nice and healthy between users, contributors, committers, and so on and so forth. So hopefully this was interesting. Again, we have a workshop coming up in I think about an hour, where we're going to get into more details as of how you can set up some of these things, or we can just get interactive. This is what we like the most. So if anybody has subjects or experiments they want to run with us using this system, we're going to be doing that. I think we're approaching the hour, so I'm going to pause here and see if there's any questions, or see if David wants to channel something. Thank you so much.
Thank you very, very much, Lorenzo. We've got you back a little bit bigger on the screen so people can see the full beard there. And we're going to give people an opportunity to ask questions. I don't see anybody coming forward right now. I looked in the chat, and I didn't see the chat in our room, that is, and I didn't see any questions there. Okay, we do have a question. Jiri is coming up. So is the mic on there, Jiri? Give it a little tap. It sounds like it is. Here's a question from Jiri, Lorenzo.
Hello, this is Jiri. So first comment, it was not boring, it was totally exciting. I was just wondering, what are all the methods, how you collect the data?
So we, up until now, as you might know, we have been using our own encapsulation protocol. So we have the HEP encapsulation protocol, which can transport anything. So that's the number one way. You can still use it also with this solution. But this new approach has an HTTP and protobuf API, where you can send basically objects in just like you would with any other platform. We make Pastash, which is basically our spaghetti machine that can take any input. So you can read logs, files, free switch ESL sockets, just anything that you can think of, and send it into this by choosing what tags it's going to have. Because again, the secret is not indexing too much. So there's a bunch of tools. You can also use Logstash from the Elastic Stack, Promtail from Grafana, FluentD, and a number of other tools. We focused everything on the ease of integration. So this is not custom, but rather us going into the direction of the global monitoring community and accepting just any format that's out there. So I would be surprised if there's something that we cannot successfully ingest in here. Maybe binary data. Thank you.
Thank you. Fantastic.
Jury's got a big smile on his face, Lorenzo. I think you successfully answered his question there. Let me just remind you, Lorenzo already said it, but there is a Homer Lunch and Learn at 1 o'clock in the lounge at the other end of the hall there. Any other questions for Lorenzo before we move on? I'll take a quick glance back at the at Alexander Dubnikov is in the chat there.
Oh, absolutely.
Yes, he's given some great answers in the chat, and also pointing to Yakin is pointing to the GitHub. So I think people are looking after each other in the chat there. So that's great.
Wonderful.
So I'm going to say thank you very, very much for joining us, and we're going to give you a big ClueCon. Thank you, Lorenzo.
Thank you for having me and for having me. And see you later for the workshop.